So the following table gives the number in millions of men and women over the age of 24 at each level of highest educational attainment. Part A asks us, what's the probability that two randomly selected females over the age of 24 are both college graduates? So we have the probability that both are college graduates here. So that's the first is and the second, and those are independent events. So first and second. So we can just multiply those, and we're looking at two randomly selected females. So our total here is going to be the total females, and we're looking at both are college graduates. So we want college graduates. So we're looking at 3 out of 103.7 here. And again, we can write that as that one fraction squared. So let's look at our decimal approximation here, and I'm actually going to square that in my calculator. So 41.3 divided by 103.7 squared. So we're looking at 0.1586 there. So approximately a 16% chance there. Part B, we want to know what's the probability that two randomly selected individuals over the age of 24 are both women. Right. So let's go ahead and write it as a squared. So we're just looking at two randomly selected individuals, so we're looking at that total, and then we're looking at women, so the 103.7. So 103.7 divided by 200, and I'm putting that in parentheses because I want to square that whole entire fraction, not just the denominator. And this is approximately 0.2688. I'm going to go and erase what I have on my table so we can do the next couple of problems here. So the next problem we have, suppose 4 people over the age of 24 are randomly selected. What's the probability at least one will be a college graduate? Right? It's a little bit different here. Alright, so a couple things we need to look at. So let's think about this. I'm going to kind of have some separation here. So probability that at least one graduate. So that is 1 minus, if at least one's a graduate, then the opposite is that none graduated, right? Right, well, let's look back at our table here. We don't have none graduated. We have just a couple of other things here. So we need to find that, right? So we need the probability that they did not graduate. Right. So to figure that out, I can do 1 minus the probability that they did. So that is 78. They did graduate. So there's our graduate. 8.1 out of 200. Alright, so I'm going to do 200 minus 78.1. So this is 121.9 out of 200. Right? And then we're looking at none of the 4 graduated, so this is 1 minus, that's the probability that 1 didn't graduate, and we're looking at 4, so I'm going to raise this to the 4th. So I can type that all in my calculator one time. So 1 minus 121.9 divided by 200 raised to the 4th. So this is approximately 0.8620. And then part D here, center page. We want to know, suppose 4 people over the age of 24 randomly selected, what is the probability that at least one will not have attended college? So again, we need to do some work here. So the probability that at least one not attended. So this is going to be 1 minus the probability that all attended. So we need to figure out the probability of attended here. So probability of attended. So let's kind of go back up here. So if they attended college, they went to some or they're a college graduate, right? So we're looking at these two totals over the entire amount there. All right, so we're looking at 33.7 plus 78.1 out of 200, or that is 33.7 plus 78.1. That's 111.8 out of 200. So this is going to be 1 minus 111.8 out of 200, and we're looking at 4 people, so I'm going to raise that to the 4th. And this is approximately equals to, so we're going to type that all on our calculator. 1 minus 111.8 divided by 200 raised to the 4th. So we're looking at 0.9024.